Okay, so this is the third chapter. What we're going to do is, so this is the book that I am using. It's available for free download here at this web address. Also, I am using the Humongous book of algebra problems available on Amazon. I got permission to use their text. I'm not going to be showing their text. I'm going to be mostly using their examples in my explanations. So now we're going to study order of operations. Order of operations are essentially when you see pluses, minus, brackets, and powers and exponents, which one do you do first? Okay, so here in the book, they show a pretty good example of how things can, if you use the wrong order of operations, you're going to get a different solution. So if we look here, we see 2 plus 5 times 3. Remember, the dot means multiply. So if you do add first, you're going to get 2 plus 5 equals 7 times 3 equals 21. However, the order of operations say that you have to multiply first. So you're going to be 2 plus 5 times 3. You're going to do 5 times 3 equals 15. Add the 2, you're going to get 17. See how you get different answers if you don't follow the order of operations? Who invented these order of operations? I have no clue. All I know is you have to follow them. So, the order of operations are as such. First, you do the parentheses, then you do the exponents, then you multiply and divide left to right, and then you add and subtract left to right. That left to right is very important, by the way. Multiply and divide are on the same level because they are the same operation. Division is just multiplying by the reciprocal. What do they mean by that? Well, if you do 1 over 4 times 3 over 2 equals, if you do 1 over 4 divided by 3 over 2, that equals 1 over 4 multiplied by 2 over 3, right? You have to inverse the fraction of which you are dividing, and then it turns into a multiplication. That's what they mean by that. That means they must be done left to right. So some problems we will divide first, other will multiply first. The same is true for adding and subtracting. So we start from the left. Students often use the word Pemdas, which I never used in my entire life, to remember the order of operations. However, it is the author's suggestion to think of Pemdas as a vertical word written as P-E-M-D-A-S. So we don't forget multiplication and division are done left to right, same as with addition and subtraction. Another way students remember the order of operations is to think of a phrase such as, "Please excuse my dear Aunt Sally." Whatever. Interesting to note that the first use of grouping symbols found in 1646 by Dutch mathematician Whatever, he used a bar over the expression that is to be evaluated first. So he would put a bar, whatever. That's interesting. I always like it when we find out, like in those textbooks, when the math first started, because it reminds me of how like insignificant I am in terms of like the learning process. Like Pythagorean theorem was like invented like before Jesus almost, you know, so it's kind of like really funny. Moving along. All right, so here we're gonna do some real examples here. So I'm gonna write it out here on the side. So we have 2 plus 3 9 minus 4 squared. So if we look at first, you have to do the parentheses, right? So it's parentheses, exponents, multiply, divide, add, subtract. So let's look at this. Do we see any parentheses? We'll start with the top. Do we see any parentheses? Yes, here. So that's what we're going to do first. 2 plus 3 multiplied by 9 minus 4 equals 5 squared. So that's done. Do we see any exponents? Yes, we do, right here. So 2 plus 3 times 25 equals. So do we see any other exponents? No. So now we do multiply and divide. Is there multiplication here? Yes, here. So 2 plus 3 times 25 equals 75. So now we are left with adding and subtracting. And that is the solution. So it is very important to remember to multiply and divide from left to right. They're right about that. Example 26, 30 divided by 3 multiplied by 2. So basically here it's multiplication and division. So let's take a look at this problemo. All right, 30 divided by 3 multiplied by 2. Now we're going to do parentheses, exponents, multiply, divide, add, subtract. Or divide, multiply, doesn't matter which order. Now, are there any parentheses here? Nope. Are there any exponents here? I don't see any. Is there any multiplication division? Yep, there's one here and there's one here. So there's nothing else really. So it's just multiplication division. So we go from left to right. So 30 divided by 3 equals 10. 10 times 2 equals 20. Now we go from left to right. Yeah. So, hold on a sec. That's our solution. In our previous example, if we had multiplied first, 5 would have been the answer, which is incorrect. So what they're trying to say is if you would have went from right to left, let's do it. 30 divided by 3 multiplied by 2. This is 6, so 30 divided by 6 equals 5. Wrong. You have to go from left to right. If there are several parentheses in a problem, we will start with the innermost parentheses and work our way out. Inside each parenthesis, we simplify using the order of operations as well. To make it easier to know which parentheses goes with which parentheses, different types of parentheses will be used. Why, that's a lot of use. I've never used so many parentheses in one sentence. So let's look at this problemo. All right, what do they have here? Now that they went really complicated on us. So 2, 8 minus 8 squared minus 7, another parentheses, 32 minus 4. It's kind of a killer problem. All right. Let's look at these parentheses. So we have one parentheses here. We have one parentheses here. And we have this one right here. So that's what we're going to do first. Let's look at this line. So what it says here is 3 to the second power plus 1. Now if we do parentheses, exponents, multiply and divide, add and subtract, let's take a look at this. 3 to the second power, so are there any parentheses inside this equation? The answer is no. It is a parentheses. Is there exponents? Yes. This guy right here, that's a 9 plus 1. Is there multiplication and division? Nope. Is there addition and subtraction? Yes. So here we have 10. Right? So now we can rewrite this problem. 2, 8 squared minus 7, 32 minus 4, 10 minus 1. So we're going to go over again, parentheses, exponents, multiplication, division, addition, and subtraction. All right, so are there any more parentheses? Yes, there are. The second one I said before right here. So let's take a look at this bugger. 32 minus 4 times 10. Now if we look here, are there parentheses in this expression? Nope. Are there exponents? Nope. Is there multiplication or division? Yes, here. So it becomes 32 minus 40 equals minus 8. So this whole thing here is minus 8. Moving along. Let's rewrite this problem now. 2, 8, 2 minus 7. We said this whole thing was minus 8. And here we have minus 1. So, once again, power, exponents, multiplication, division, addition, subtraction. Do we have any, not powers, parentheses. Do we have any parentheses? Yes, this one right here. This one is left. So 2 times, now, actually, we're going to do just this. 8 squared minus 7 multiplied by minus 8 multiplied by minus 1. I don't have to put these dots. I'm just putting them there to show you that it's another way of showing multiplication. So, do we have any parentheses in this expression? No, we don't. It is the inside of parentheses already. Do we have any exponents? Yes, we do right here. This bugger right here. This bugger right here. That's 64. 8 to the second power is 8 times 8, which equals 64. And then we have minus 7 multiplied by minus 8 multiplied by minus 1. So, do we have any multiplication or division? Yes, we do right here and right here. So it's going to be 64 minus 7 times minus 8 equals positive 56 multiplied by minus 1. So what are we left with here? We're left with an addition and a multiplication. So we have one more multiplication to do. 64 plus minus 56, right? 56 times minus 1 equals minus 56. 64 minus 56 is 8. So that should be our answer. So, because the last step was the addition. So let's see if I'm right. No. 16. Am I forgetting something? Oh, yes. 2. Remember this guy here? So 8 represents this brackets times 2 equals 16. Woo! That was embarrassing. All right. So that is the first problem. All right. Do we have time to do number 28? I think we do. Number 28 is easier. Let's take a look at this. Minus 8 times 3 over 15 divided by 5 minus 1. Okay. So what we do is we do one floor. We do each floor, even though it's like a division, and you'd be saying, well, I have to do the power, and when do I do this division? No. The way it works is when you do a division problem like this, you do one floor at a time. So what we're going to do is here, so there's no parentheses, there's an exponent, there's multiplication, division, and there's addition and subtraction. So this guy here, 2 times 2 times 2 times 2, that's what 2 to the 4th power means. So 2 times 2 equals 4, 2 times 2 equals 4, that equals 16. So we have 16 minus negative 8 times 3 over 15 divided by 5 minus 1. Now we have a subtraction here and we have a multiplication here. So that's what we're going to do first. 16 minus negative 8 times 3 equals negative 24. But wait a minute, we have two negatives here, so that's a positive. 16 plus 24, and that equals 40. 16 plus 24 equals 40. So that's the top part. So let's rewrite this. 40 over 15 divided by 5 minus 1. Now if we look here at this expression, there's no parentheses, there's no exponents, there is a multiplication and division here. There's a division right here. And then there's an addition. So we do this first and then we do that. So 15 divided by 5 equals 3 minus 1 equals 2. So the answer is 40 over 2. 40 divided by 2 equals 20, and that is your solution.